Okay, so day 12, back of your packet. Question 3. This is a parallelogram. Hopefully you guys are marking your diagram because I told you 2 line segments were perpendicular, 2 angles are congruent, and we're looking for angle CDE. All right, let me start with somebody first. If those 2 segments are perpendicular, what are you putting on your diagram and where are you putting it? Let's do this. Start it off right. Sure. Where are we going? EC perpendicular to DC. What's going on your diagram? A right angle. Right here at angle DCE should be a right angle. We're told that B and E are congruent. All right, here's your first property of the day. I know angle A is 100, so we should know what angle B is based on a property of a parallelogram. Look at your chart if you need to remember. Those are called consecutive angles right there, kids. Consecutive, not opposite. A and B are consecutive, right in a row. So how can I find angle B? Little help. How can I find angle B? Let's start this, Finley. Darn right. Consecutive angles are supplementary. You don't know that property. I can't help you on Thursday. No way you're going to do the problem. All right. No way you can do the problem. So that's going to be 80 because they're supplementary, which also means angle E has to be 80 because they're congruent from the givens. All right. Take it over now. Now find angle CDE. This has nothing to do with the parallelogram. Measure of angle CDE now. Nothing to do with the parallelogram. Little help? How you finding angle CDE up here? Little help. Cormac?
You do 90 plus 80 and then subtract it from 180.
Yep, that's a triangle. And I know 2 out of the 3 angles. So subtract the 2 from 180. Looks like that's going to be a 10-degree angle. Okay. Consecutive angles, supplementary in a parallelogram. Consecutive angles, supplementary. We good with 3? Any issues there? All right, let's go to 6 now. I'm skipping around. 6. Now we change our attention to a rectangle. Rectangle. Are those 2 triangles, BAD and CDA, congruent? Make sure, find out where they are. Locate them first. I should have probably handed out colored pencils, but this will probably be the only time we'll need them. So it should be fine. All right, I'm not doing a whole proof here either. We're not going to do statements, reasons. Look, BAD and CDA. Are these 2 triangles congruent? If they are, we're going to have a method. One of the 5 methods. My first question for somebody, are there any sides or angles you know are congruent so I can mark them if this is a rectangle? So look at your properties of a rectangle. Name a pair of sides or angles in those 2 triangles you know are congruent. Anything. Let's start it off. Jonathan, anything.
80 is congruent.
Okay, we got reflexive side right there. We're good there. We got a reflexive. There's 1. Name more. More. Give me another sides or angles, I don't care, that are congruent up here. 1, 4. Stephanie, anything else? Opposite sides in a rectangle are congruent. We're moving right along now. So it looks like I need 1 more pair to make these congruent if we have it or not. I think we do. What else can you tell me about these 2 triangles? Anything else? It's a rectangle. A rectangle. What else? 1 zip. Henry, what else?
BA is congruent to CD.
Okay. B, say that again?
BA congruent to CD.
Yeah, we got that. Thank you. We got that one already. Anything else because it's a rectangle?
BB is congruent to CA.
BD and CA. Diagonals of a rectangle are congruent. I'm good there. You could have also told me these are right angles because it's a rectangle. That would have worked too, all right? But let me stick with Henry's. BD and CA because diagonals of a rectangle are congruent. Perfect. I think those 2 triangles are congruent by what method now? What do I have there? Side, side, side. Yep. Or we could have done side angle side if you saw the right angles. So yes, by side, side, side. There you go. We just flew through a bunch of we're not even done with this yet. All good on why they're congruent. All right. Next up, part B. I don't know if this property is listed in the flow chart, but we definitely wrote it down on rectangle day. Let's see, CAD, that angle right there is 3x minus 22. This angle right here, x plus 14. And we're looking for AED, that angle right there. If anybody's thinking, oh, this is an easy question, it's 90 degrees, they're perpendicular, that's a rhombus. This is a rectangle, that's a rhombus where those are perpendicular. Not in this figure. All right, this is a rectangle. Whew, what do I know about those two angles down there? I don't think I put it on your flow chart. Nope. But it is on when we wrote it down. Diagonals of a rectangle. Yes, they're congruent, but they also form 4 isosceles triangles. Okay, diagonals form 4 isosceles triangles. Why am I telling you that? That they form 4 isosceles triangles. Cormac, what's across from those congruent sides? There you go, the angles we're looking for. So the diagonals form 4 isosceles triangles. So that's why we can set 3x minus 22 equal to x plus 14. I will let you guys take it from here. We are not finding x. That's not my answer. You need to find x to substitute back in. And remember, we're looking for angle AED. We should be getting x equal to 18, and then I'll let you guys do your thing, substitute, and put it back in to find angle AED. All right, when you're ready, AED, angle AED, what did we come out with? When you're ready. Alyssa, when you're ready?
116.
Buck 16, sounds good to me. Yep. Questions on how we got there? Rectangle properties for that one, rectangle. We're good? All right, let's keep cruising. 8, I'll just let you guys read 8, look at your properties if you need to, and figure out which one it's going to be. Diagonals of a parallelogram are perpendicular but not congruent. Can we at least eliminate one of these choices right away? Because we're talking about a parallelogram, aren't we? So which one are we eliminating right away here? Trapezoid's gone. No way could it be an isosceles trapezoid. That's not even a parallelogram, type of parallelogram. So it's down to these 3, and this is straight up properties. And I think this is similar to the first question I'm going to ask on Thursday. It's just a straight up properties question. Which one are they perpendicular but they're not congruent? Perpendicular but they're not congruent. Cormac, what do you got?
Square.
They are congruent in a square though. Diagonals are congruent in a square. They're congruent, and remember, squares got everything. Squares got everything. Now we're down to a rectangle and a rhombus. Which one are the diagonals perpendicular? What's that?
Rhombus.
That's it. I don't know. I don't have any teaching strategy there for you other than we got to know the properties, right? Okay. Diagonals of a rectangle are congruent. Diagonals of a rhombus are perpendicular. They form right angles. All right. Not much else to say there. Let's go on to 9. This was day 1. Here, question 9. How many sides does it have if each interior angle is 144? If we're doing this, oh, I remember that. 180 times n minus 2, that's equal to 144. No. This is for the what? That's for the sum of the interiors. Is 144 the sum? No, that's only one angle, so I can't do that. I'm not using it correctly. That's not correct. The sum isn't 144. It's only one angle is 144. So here's what I'll have you do instead. If the interior is 144, can you guys help me find what the exterior angle would be then? Not 360. I'm looking for the one exterior next to it. And remember how it works. I don't know what this figure looks like, but if this is 144, the interior, how do I find the exterior then? What's the relationship? Whew. Jonathan, what's the relationship between these two? Supplementary. So if that's 144, what's the exterior have to be then? Yep. Crunch it out here quick. Crunch it out. Finley? 36. Now, why am I having you find the darn exterior when I need to find the number of sides? What do all these add up to? I don't care how many sides it has right now. What do they all add up to? 360. So I can take 360 and divide it by that exterior angle. I can't do that with the 144 because I don't know what they all add up to. But you know what I know adds up to 360 is the exteriors. All right, so that's why I always want you to try to find the exterior. You already know what they add up to. So how many sides does this bad boy have? Stone?
10.
10 sides. Find the exterior. Okay, find the exterior. Because you already know it's 360. I have no idea what to divide 144 by though. But I know I can divide by 360 with the exterior. All right, go to 10. Back to the parallelogram and its properties. 10. It's a parallelogram. SH bisects MHT. I'm going to start there with you guys because there should be some markings you're putting on your diagram. If SH bisects MHT, I'm going to ask somebody what two angles are congruent then. Name the two angles in the diagram that are congruent if SH bisects MHT. Name the two congruent angles up here. Micaiah, name them.
MHS and THS.
Good job. So everyone has these two marked congruent. All right, now let's go parallelogram properties. What is angle H? Angle H, MHT. All of angle H is how long? Or how big, excuse me. Use your properties. Stellan, what's angle H? All of it.
Like, what do you mean?
How many degrees?
Oh,
You already know T's 100. T and angle H are called consecutive angles because they're right next to each other.
yeah.
So what do I...
so they're supplementary.
Yep, so
80.
80 degrees. Why do I ask that? Because it's getting bisected. So we can put 40s there. 40s there. I know. I got to get to this angle right here, right? HSA. I got to get to that angle. I am. Not right now, though. There's no way I can get to it right now, but I'm getting there eventually. What's angle M now? How many degrees in angle M? Use another property. All right. Angle M. What do you got for me? Angle M. How many degrees, Shar? 100. Opposite angles congruent. We're getting there. And now I'll let you guys find that missing angle. All right. You know, look at triangle MHS. You know 2 out of 3 angles in that triangle. Find the third one, and the missing one's right next to it. So go ahead, finish this off now. Missing angle in triangle MHS should have been 40. The one right next to it, supplementary to it, subtract from 180. Hopefully we got 140 out of that. Okay, 140. But you needed parallelogram properties to do that. No shot at, my goal before you leave, you guys have no shot at these problems unless you know your properties. Right? There's no way I'm going to know that this is 80 degrees without knowing my property. All right, let's keep trucking. What's up next here? 16. Back to a rectangle. This is a rectangle. Hopefully you're putting some markings on your diagram that help you out with these angles. It's a rectangle. What are you adding to your diagram? I don't care about the sides, right? We don't care that AD and BC are equal. I don't care. We're talking about angles in this problem. So what else are you adding to this diagram as far as angles go? What else can I add? Char, go ahead. Yep. Angle D and angle C are right angles. All right. Now you should be able to find the missing angle of triangle ADE and the missing angle of EBC. Find the missing angle of each, and then we'll talk angle X here at the end. All right, missing angle of ADE, we got 60 degrees down here. Missing angle of EBC, what do we have? 70? All right, now let's talk X. 60, X, and 70, what do you know about them? 60, X, and 70. Stellan, what do we know about them?
They're supplementary.
Easy. They do add to 180. I don't want to call them supplementary because that's for two angles. All right, but yes, they do add to 180. So we get the point here. So X is going to be 180 minus those two. Form a straight line. Nothing fancy there. And 50 spot. Angle X. Go to 20. Let's talk about trapezoid. One thing I just want to say before we get going is it's just a trapezoid. I didn't put the word isosceles with it. So it's just a trapezoid, not isosceles. So this is it right here. One pair of opposite sides parallel. No more properties. Okay, isosceles, there might be other properties we could use, but this is just a trapezoid. Oh boy, here we go. Angle BDC. And there should have been a reason why I told you those lines were parallel, right? Angle BDC. There's really no calculations here. Just look where angle BDC is and look at the two angles I gave you. There's BDC and the two angles I gave you. Anything here you want to throw at me here? Alyssa, anything? Look at the 20 degrees I gave you. And angle B. Go ahead, sorry.
It's 20.
Why? They are?
Alternate interior.
Done. Done. Alternate interior. Not much else I can do there for you. 20. And then you guys hopefully will be okay now for angle DBC. DBC is not 20. They don't bisect. Okay, that's not a property. How you find an angle DBC now? DBC, little help, Melissa again.
7 plus 20 minus 180.
180 degrees. I know two angles. Done. I'd say 90-degree angle up there. Good. All right, time to do a proof. Little statements, reasons. There'll be one on your test. Go to 24. We're only going to do part A. All right, I don't need you to do part B, so you can cross out part B for me. All right, we're not going to get in. I just want you to prove the triangle's congruent, knowing that this is a square. All right, so set up what you got to set up. Take your time, and I'll start asking questions in a minute. My first question, AE and AF, can I count those as full sides? AE and AF, can I count those as full sides in these two triangles I'm proving congruent? Can they count as an S or can they not? That's all I'm asking. Am I going to put an S in parentheses next to these or not? Yes, I am. They're full sides in both triangles. So I need your help coming up with two more pair. Two more pair. Something you see on your own, or you know it's a square, so this is true. Anything you see on your own, or the fact that it's a square. Here we go. Dylan?
BA and BD, or BA and AD.
Yep. Square, all sides are congruent, but I don't need all sides. I just need these two, BA and AD. Good deal. BA congruent to AD. Let's just remind ourselves why. The given was it's a square, so we can write, I guess you could write parallelogram down too, but square implies, and then the property you just used to say they're congruent, which was square, all sides congruent. There's another side. All right, so I need one more pair of something here. One more pair of something. All right. What else do we see here? Brendan?
Angle FAB is congruent to angle DAE.
Yep, you guys got vertical angles right here, right? You got verticals. Good. Angle FAB congruent to EAD. Not a square property, just vertical angles congruent. And that gives me an A. I think we're good. Triangle BAF congruent to triangle DAE. All I need, Y. What's my method here? Vinny?
Side angle side.
Yep. Not saying the one on the test is going to be that easy, or it's going to be a square. It could be another figure. But questions? Looks like we'll have plenty of time to do the coordinate proof. So let's do the coordinate proof. 27, everyone. I'll give you time to graph it. All right, I'm going to do this the same way with all you guys, but remember there's multiple ways of doing this, but there's a certain way I want. I know Friday before break, hey, some of you weren't happy. I was asking you for more details. That's the way it is. Sorry. All right, and if you don't want to do it that way, prepare to get points off. All right, there's one way we do this and one way only. So whoever's going to get called on here, and you're going to make the big class decision because there's a couple ways I could do this. All right, couple ways you could prove it's a parallelogram. Well, I'll talk about not a rectangle, but we got to get a parallelogram first. How do you want to show it's a parallelogram? By doing what? We got a lot of options, but we're only going to do it. Go ahead, Brendan. You're making our decision here.
With the opposite sides parallel.
Okay, that's done. All right, that's all right. If you guys are, you could also do opposite sides congruent if you guys prefer that. We're going to do opposite sides parallel. So to show that, I'm going to need to use what formula here to show opposite sides are parallel, Finley? Slopes, all right? We're going to use slopes. And when I say slopes, rise over run. So we can take our time right now, find the slope of AB, find the slope of BC, find the slope of DC, and find the slope of AD using rise over run. Up and over how many? And hopefully we notice something that makes it parallel. Go ahead, find your slopes. You guys prefer distance formula on the test? Hey, go ahead and do distance instead. Three over 8, 5 over 2 for both. Both are positive. All right, none of the slopes are negative because you're going up and to the right for both sets. Any issues getting those, or maybe I counted wrong? All right, here we go. Step 2, and again, I need to see all this work here. Step 2, what did we just learn from step 1? We didn't learn it was a parallelogram. We haven't learned that yet. What did we learn about AB, DC, and BC and AD? What did we learn about those lines? Here we go. Bailey, what did we learn?
AB and DC are parallel.
Okay, yeah, just one sec. We learned AB and DC were parallel along with, go ahead.
BC and AD.
BC parallel to AD. That's what we learned. So let's write that down because how do we know that's true? True, Simon. Why is that true?
Their slopes are equal.
Done, because slopes are equal. So step 2, tell me what you learned from step 1. Now we can say it's a parallelogram. ABCD is a parallelogram. Because How do we know? Look at your work we just did. Look at the work we just did. Vinny, why is it a parallelogram?
Opposite sides.
Are they?
Or parallel.
There we go. Half of it done now, right? Half of it. Now we got to continue on and say why it's not a rectangle. All right, well, what do rectangles have that it doesn't look like it has here? Jared, what do rectangles have that it doesn't really look like here?
Right angle.
Right angles, right? So how can I show there's no right angle? Well, good thing we picked slopes. What should I know about two slopes if there's a right angle? What should I know about two slopes if there's going to be a right angle? They should be what of each other if it's going to be a right angle? Stephanie? If two lines are parallel, the slopes are equal. If two slopes are if two lines are perpendicular, aka they form a right angle, what do I know about the slopes? They're not equal, they're what of each other? Like one would be 5/2, the other would be -2/5. Right there, I would know that that forms a right angle. Why? Because they are, what's the term we use? That means add to 180. I don't know, throw that out. Negative reciprocals, right? If they're going to be perpendicular, they're negative reciprocals. And Stephanie, are any of these negative reciprocals of each other? Nope. Everyone see that? All right. So we can go number 4. ABCD is not a rectangle because slopes are not negative reciprocals. You cannot tell me it has no right angle. I need to know why it doesn't. All right, right? By saying that it's not no negative reciprocals, you're telling me what's going on here. No negative reciprocals. All right, just don't say because it doesn't have a right angle. All right, well, y doesn't have a right angle. There you go. Slopes are not negative reciprocals. Okay, questions? All right, continue on in your packet anywhere you want. We'll go over a couple more questions tomorrow.